This lesson is about graphing linear inequalities in two variables. The first thing we're going to do is determine whether an ordered pair is a solution. So all we have to do is plug in the appropriate values for the right variables and look at our sentence and see if it works. So I'm going to put 5 in for x, 15 in for y. So we're going to get 25 minus 15 is greater than 10. 10 is greater than 10. No, because 10 is equal to 10 and there's no equal to here. Therefore, 5 comma 15 is not a solution to the inequality. Okay, there's my inequality. The next one, let's put in negative 1, 2 into 2x plus 3y is less than 10. Two times negative 1 is negative 2, plus 6 is less than 10. Is 4 less than 10? Yes, it is. So 1, 2 is a solution to the inequality 2x plus 3y is less than 10. Now let's take a look at C. This is the only one so far where we've had an equal to in it. So I'm going to pop negative 2 in for x, 3 in for y. Negative 2 times negative 2 is regular 4. So 7 less than or equal to 4. No. So negative 2, 3 is not a solution to the inequality. Didn't plan ahead on that one. All right, now let's graph them on an XY plane. First, let's label our little happy XY plane. And we are going to sketch the corresponding line. So the first thing we're going to do is sketch the boundary. This is our equal to. But before we do that, we want to decide whether it is a solid line. So do we want to include the boundary or not? Well, since it's equal to, we're going to draw the line to be solid because we want those points where x is equal to negative 2 as well. So let's plot this line, and again, you guys are getting pretty used to plotting these. X is always negative 2, y could be anything it wants to be, and then we're just going to draw the line here. Okay. Then I'm just going to write the word solid here so that we remember that we drew a solid line. The second thing is to pick a point not on this line boundary. So we don't want to pick this or up here or there. Let's pick a point not on the line. The origin is really an easy point to pick if it's not on the line. So now we're going to plug it in. We just need the x value from this. Okay, so the point is right here. Okay, when I plug in that point, 0 is greater than or equal to negative 2. It's true. So since it's true, we want to shade toward the point 0, 0. On my math lab, it'll be a little paint can. And there is my solution. If I pick any point in here, it will satisfy this inequality. X is greater than or equal to negative 2. Now, let's look at this one. I'm going to graph this inequality. So the first step is to decide whether we're doing a solid line or dashed. And and it's solid because it's greater than or equal to. If it were less than or equal to, it would also be solid. Dash is strictly greater, strictly less. So since we're in this area, we're solid. And we have to graph the boundary. So we always start with the line that I call the boundary. Okay, we need to know where to put our fence. So that's the absolute last area before we're in or out of the solution. So this one's really nice because my slope is equal to 5 over 1. My y-intercept is -3. So I label my cute little axes. I start at -3. I'm going to go up 5, right 1. There's my line. It's solid. Not drawn super great. Step 2, pick a point not on the line. Well, 0, 0 again is not on the line, so we might as well pick that. And you place it into the original inequality. Put in 0 for x, 0 for y. Is 0 greater than or equal to -3? Yes. So we're going to shade in this direction. Okay, so I do my little shading glasses. Get it? Shades. All right, next. Now let's graph this line. First, let's decide whether it's solid or dashed. Well, since it's greater than strictly and there's no equal to, it's dashed. And we're going to graph the boundary, you guys. And the boundary is your fence. It's always where it's equal to. This one's also very nice because you can think of it as y is equal to 3x plus 0. So the slope is 3 over 1. Your y-intercept is 0. Label your cute little axes. And we start at 0, go up 3, right 1. You can go down 3, left 1 if you want to. And we're going to dash the line. Dashed is usually easier for me, but maybe not today. Okay. Now the problem with this one is it goes right through the origin, so you have to pick another point. So I'm just going to pick a random point. 1, 2, 3. Let's pick the point 3, 0. And we have our original inequality. I'm going to put 3 in for x, 0 in for y. 0 is greater than 9. No. So since 0, this doesn't work out, we're going to shade the opposite side. Okay, since this side was a big NO, we're going to shade the other side. Okay, let's graph this one. The other ones were in slope-intercept form for the boundary. This one will not be, so I'm going to graph it slightly differently. So step 1, we have to figure out whether it's solid or dashed. Well, it's dashed because it's greater than. So we're going to graph the boundary now. 3x plus 4y equals 12. And yes, I can put it into slope-intercept form if I want to, but let's just graph using the intercept method. 0 for x, 0 for y. If I put 0 in for x, y is 3. If I put 0 in for y, x is 4. So I'm just going to graph the 2 points 0, 3 and 4, 0. And draw a dashed line. label, and we're getting there. Oh, this one we can choose 0, 0. I'm psyched because 0, 0 is not on the line. So we're going to plug it into the original inequality. There it is. Put 0 in for x, 0 in for y. 3 times 0 is 0. 4 times 0 is 0, so 0 is greater than 12? No. See, here's my 0, 0. It's a big NO because it's not greater than 12. So we're going to shade the opposite side. And now you'll be ready to do the lesson associated with this lecture.